Good evening. Look around this room for a moment. Every thought, every feeling, every memory that defines you as an individual is the product of one single 3-pound organ, the human brain. For millennia, it was the ultimate black box. We could study the heart, the lungs, the bones, but the source of consciousness, of self, remained a mystery wrapped in a protective layer of skull. Today, that black box is finally yielding its secrets, and the field dedicated to this quest, neuroscience or brain science, has become the most uniquely powerful and disruptive field of the 21st century. What makes brain science unique? It is the ultimate interdisciplinary science. Traditional fields are defined by their subject. Physics studies matter and energy. Chemistry studies composition. Neuroscience's subject is the most complex object in the known universe, a network of roughly 86 billion neurons with trillions of connections. To understand this complexity, we can't afford to be siloed. Neuroscience is not just a branch of biology anymore. It's a vast, collaborative ecosystem. Molecular neuroscientists dive into the signaling molecules and ion channels that define a single neuron. Systems neuroscientists map the large-scale circuits, the networks that control our vision, our language, our motor skills. Cognitive neuroscientists bridge the gap to psychology using advanced imaging to see memory, attention, and decision-making happen in real time. Computational neuroscientists apply advanced mathematics, coding, and deep learning to model the brain's functions, creating digital brain twins that allow us to simulate neural disorders. No other field of study so seamlessly integrates pure biology with mathematics, engineering, computer science, and even philosophy. This collaborative, multi-scale approach, from a single molecule to an entire conscious mind, is its profound and defining strength. The most immediate and critical usability of this research is in human health. Neurological and psychiatric disorders affect billions, yet for decades treatment has lagged. Brain science is changing that with two major trends. We are no longer satisfied with low-resolution glimpses of the brain. The development of ultra-high-field MRI, with magnets reaching 11.7 Tesla, T, is providing unprecedented anatomical resolution, allowing clinicians to map brain tumors, microvascular changes, and epileptic foci with a clarity that was science fiction just a few years ago. Equally important are the new portable MRI units. These low-field, cost-effective machines can be deployed in ambulances, ICUs, and rural clinics, dramatically speeding up diagnosis for stroke and trauma, democratizing access to brain health technology globally. The old belief was that after childhood, the brain was fixed. Modern neuroscience has soundly debunked that. Neuroplasticity, the brain's ability to rewire itself, is now the core of next-generation therapies. In stroke rehabilitation, researchers are combining augmented reality, AR, and brain-computer interfaces, BCI, to provide real-time feedback, engaging neural circuits, and accelerating recovery. For Parkinson's and Alzheimer's disease, new breakthroughs in identifying specific proteins, like alpha-synuclein, and brain circuits are paving the way for targeted drugs and advanced deep brain stimulation techniques. Furthermore, BCI technology is beginning to restore vital functions, like speech for patients with paralysis. And finally, in the realm of mental health, AI is analyzing neuroimaging data and electronic health records to predict and subgroup conditions like depression and psychosis more accurately than ever before, moving us away from one-size-fits-all treatments toward truly personalized care. If health is the primary application, then the profound synergy between neuroscience and artificial intelligence, AI, is the most revolutionary. This relationship is a two-way street. AI for neuroscience. AI models, particularly deep learning, are essential tools for managing the sheer volume of high-dimensional neural data. They can analyze complex neuroimaging scans to detect subtle patterns indicative of disease, process massive electrophysiological signals, and even model how different drug compounds interact with neural circuits. AI is the lens through which we now view the brain's enormous complexity. Neuroscience for AI, but the brain is also the ultimate inspiration for AI. Artificial neural networks, ANNs, were modeled on the brain's architecture. As neuroscientists uncover more about energy-efficient computation in dendrites, synaptic plasticity, and the brain's fundamental wiring, we are providing the blueprints for the next generation of AI. Concepts like neuromorphic computing aim to replicate the spiking, energy-efficient nature of biological neurons in hardware, promising a future of exponentially more powerful and sustainable AI. The goal is not just to build smarter machines, but to use them to understand ourselves. Beyond the hospital and the lab, brain science is increasingly informing how we learn, interact, and govern ourselves. In education, the field of neuroeducation uses principles like neuroplasticity and cognitive load theory to design more effective learning systems. AI-driven adaptive learning platforms personalize curricula based on a student's demonstrated cognitive patterns, optimizing memory retention and engagement. Virtual reality, VR, and augmented reality, AR, are being developed for immersive, brain-based learning environments. On a societal level, social and cultural neuroscience studies how biological systems implement social processes, providing profound insights into complex human behaviors. It helps us understand the neural basis of trust, empathy, and prejudice. It informs public health campaigns by revealing the brain's reward centers and decision-making processes, which can be harnessed to combat addiction and encourage healthier lifestyles. Even in the fight against online misinformation, principles from cognitive psychology and neuroscience are being applied to create frameworks that help users identify and resist the prompting of deceptive information. The science of the brain is the science of us. It offers the key to conquering devastating diseases, creating intelligence far beyond our own, and fundamentally reshaping human potential. But this power comes with a monumental responsibility. As we move closer to digital brain models and sophisticated brain-computer interfaces, we must grapple with the ethics of neurotechnology, data privacy, informed consent, and ensuring equitable access to brain-enhancing technologies. Neuroscience is not just unlocking the secrets of the brain, it is unlocking the future of the human experience. It demands our best minds, our deepest ethical consideration, and our full support. Because the most valuable frontier we have left to explore lies not in the stars, but within the 3 pounds of matter between our ears. Thank you.